Okay. So in the previous classes, we were discussing regarding the unit flow diagram of your water treatment plant. In a water treatment plant, right, we are going to have the raw water first. Then the raw water is going to be passing through the screens. So in screens, all the larger floating material is going to be get removed. The larger floating material will be removed from the screens. Then it is going to pass through your preliminary sedimentation tank where the suspended particles are going to get settled down by its own gravity, by its own weight. It is going to get settled down by its own weight, right? Then it is going to flow through your aeration tank where it is going to have your DO content is going to be increased by allowing the water to fall from a certain height. Okay, so that this is how your aeration will be done. Then we will be having the coagulation sedimentation, right? That is a clarification or the clarifier we call it as, right? So in the clarifier, we are going to have the coagulation sedimentation. After clarifier, right, the water is going to pass through these particular filter. Okay, so from your clarifier, the water is going to pass through your, right, the filter. Now in today's class, we will be discussing, right, in today's class, we are going to discuss regarding what is filtration. Okay, in today's class, we are going to discuss regarding what is filtration. Okay, so here we are going to see in detail, right, what is regarding what is filtration, right? In today's class, we are going to see regarding what is filtration, why filtering is going to be important, right? And after filtration, we are going to have a disinfection, right? Now, in today's class, we are going to discuss regarding filtration, why it is important, its construction part, how many types are there in the filtration process, right? And why and what are the different materials we are going to use, what is its efficiency, right? Everything that we are going to discuss regarding the filtration, right? Everything we are going to discuss regarding the filtration. Okay, so let us directly discuss on the filtration part. Okay, do you have any idea what do you mean by filtration? Do you have any idea? Anybody is having any kind of an idea what is filtration is? Yes.
Removing impurities.
Removing impurities. What kind of an impurities will be there? What kind of an impurity? See, we have done screening, we have done coagulation sedimentation, right? So what else will be there, right? We have removed the suspended particles. Then what we are going to do in the filtration process? Can anybody will be giving me certain idea on that, right? Can anybody give me certain idea on filtration? What we are going to remove? See, you have seen the normal filters, right? In your houses might be filters, probably it is there. If not, aquaguard and all, candle filters are there, right? Have you seen candle filters? Candle filters. Have you seen it? Yes, Manoj.
Yes,
Okay,
sir.
what will be there in the candle filter? What will be there in the candle filter? Or sometimes if you clean those filter, what you are going to observe in that? What you have observed in that? Hmm? Irshad, what you have observed in the
So
filters?
the sand part.
Okay, there will be the
The
sand
sand.
particle will be there. Okay, but what it is going to clear or what it is going to filter? It is going to filter
Water.
what or it is going to remove what? Hmm? It is going to
Water.
remove what? What it is going to remove?
Said sand particles.
No, it is remove. It is going to remove the finer suspended particle which are not going to settle down by your coagulation sedimentation, whatever the particles has not been settled, right, all those particles it is going to remove by having the coagulation in your filtration process. Whatever the particle that we have not removed from your sedimentation or coagulation sedimentation, all those particles it is going to remove. That is the work of your filtration process. Let me explain the phenomena, what the filtration will do, right? So here in coagulation sedimentation tank, right, we have done the flocculation process. We have done the flocculation process in your coagulation sedimentation. See, we have removed the larger particles from water. We have removed the larger particle from water. It is going to form the, see, these suspend, all the suspended particles which are present in water, they will combine each other and they are going to form the ball like structure, right? They are going to form the ball like structure, and then they are, due to its own weight, it is going to get settled down. By its own weight, it is going to get settled down, and we are going to remove all those suspended particles. We are going to remove from water. But, right, but what will happen is, right, even though if you have removed all those suspended particle, right, from water, right, there will be, right, there will be few more particles, there will be few more particles will be there still in the suspension in water. If we do not remove these kind of a suspended particle present in water, our water, it is not, say, it is completely purified. It is not completely purified. Okay, if these suspended particles still, if it is not, it is there in the water, then we cannot say this particular water is completely purified. Okay, it is not completely purified. Okay, so this suspended particle which are present in water, it has to be removed, right? If we don't remove it, right, if we don't remove it, even though after doing sediment coagulation or even though after sedimentation, we will be having, right, these fine suspended particle, all these fine suspended particle which has not been removed by your sediment, your coagulation sedimentation. Here we are going to remove it with the help of filters. Okay, so if we don't remove it, right, if we don't remove it, especially we are going to get, even though we do the filtration, even though we do the coagulation sedimentation, especially in the rainy season, we are going to get the turbid water, right? Even though we do the filtration, even we do the coagulation sedimentation, what will be happening is the concentration of all those finer particles will be more. Okay, so what will happen? It is going to, say, indicate the turbidity in water. If we don't remove, it is going to show some amount of turbidity in water. Okay, it is going to show some amount of turbidity in water. Okay, so this is how we have to remove, or else it is going to say some of the organic microbes, right, some of the organic microbes or some of the microbes may develop due to, if we don't remove these fine suspended particle which are there in the water, and also it is going to impart, right, it is also going to impart some amount of turbidity in water. So our work is to remove that, right? It is our work to remove all those finer suspended particles which are present in water. Okay, now here, by using the filters, we are going to remove all these fine suspended particles which are present in water. Okay, now here, by using filters, we are going to remove such a fine elements which are present in water. So we will see how many types of filters we are going to have. We are going to have three types of filter, right? We are going to have three types of filter. One is slow sand filter, one is rapid sand filter, one is pressure filter. Slow sand filter, rapid sand filter, and pressure filter. Okay, so in the filter, right, it is going to be classified as slow sand filter and rapid sand filter. Slow sand filter or rapid sand filter, then rapid sand filter, it is going to be further divided into, right, pressure filter. Right here we are going to see regarding the pressure filter. So main filter is going to be divided into three types: slow sand filter, rapid sand filter. Rapid sand filter will be further divided into rapid gravity filters and the pressure filters. So in our study, we will be concentrating our study on the slow sand filter, rapid sand filter, and pressure filters. Slow sand, rapid sand, and pressure filters. Okay. So then, when based upon the consideration of gravity and pressure, the filters are going to be classified into the gravity filters and pressure filters. So in gravity filters, we are going to have the slow sand filters and the rapid sand filters. And when we are going to apply the pressure, we are going to classify it into the pressure filter. Okay, now here what is a gravity filter? When we are going to remove the particles, right? When we are going to remove the particle, when we allow the water to flow in this particular filter, when the particles are going to get settled down by its own gravity, right? Or by we are going to remove the suspended particles by its gravitational force, then we call it as the gravity filters. When we apply certain kind of a pressure, right? When we apply certain kind of a pressure in order to filter it, then we call it as a pressure filter. So your slow sand and rapid sand filter are nothing but these are the types of gravity filter. Okay, because here we are not going to apply any kind of pressure. We are not going to apply in case of your gravity filter. Here, in case of pressure filter, we will be applying, right? We will be applying the pressure to water so that it is going to be filtered. That is the reason why we are going to call it as a pressure filter. Okay. Now we will see what is a slow sand filter. Okay. Now here, I'll simple concept of the slow sand filter. This diagram we will have try to concentrate, right? So as I have told you, right? As I have told you that these are your slow sand filter is nothing but it is an classification which comes under your gravity filter. It is going to come under the classification under the gravity filter. So here, what is going to happen is when the particle are it is a suspended particle, though it is suspended, but still it is going to have some weight. It is going to have some specific gravity. So all these particle, when it is not going to get settled down by when the particles are going to get settled down by its own weight, it is going to remove. So in your filtration, the one thing you need to keep in your mind that in order to have the filter, we will be removing the two materials. We will be using the two material. One is sand and one is gravel. In case of your filters, sand filters, in case of your houses, you have used this particular sand. Okay, in order to remove the finer suspended particle. Now, if they have cleaned the filter which is there in their houses, right? If they have clear or they have washed the filter which is there in their houses, right? They will be seeing that very finer suspended particles. They will be cleaning it if they have cleaned it. So when you wash it, very fine suspended particle will come out from that particular pores of sand. Okay. So here, similarly here, in case of your municipal supplies and all, we will be using this particular slow sand filter. But nowadays, the slow sand, the reason why we call it as a slow sand filter is the rate of filtration, right? Slow sand filter, right? Now the water here, the phenomena what we are going to use is now if we fill it by sand, right? So what will happen? If you pour the water in sand, the water will pass, right? So why we are going to use sand in case of filtration is, right? So if we place a sand over here, right? If we place a sand over here, what will happen? Since there are some pores are there in this particular sand, the water will easily pass. But if it is going to have some of the suspended particles, these cannot pass through this particular pores which are present in sand, and they will be get arrested in this particular layer, right? So water layer is there, sand layer is there. So it is going to be getting arrested in this particular layer of sand. Since it is since the pores are there, the water is going to immediately it is going to pass. But if it is going to have some of the particles, it is not going to pass through these particular pores. It is going to be get arrested in this particular pores. So this is how we are going to remove the fine suspended particle which are there in the water. And below the sand, we are going to have the gravel, right? So if if very fine suspended particles, if it is going to come, right? If it is going to be get arrested over here, suppose due to the say pore size, some of the suspended particle, if um, it is very fine here, it is going to be get arrested over here, right? And then the water is going to pass through this particular sand layer, and then it is going to pass through the gravel layer. Here, in case of sand also, or in case of gravel also, very finer particles, right? In sand also, we are going to have the classification, right? Your very fine sand, medium sand, and a gravel, say bit larger sand, we are going to keep in terms of layer. Very fine particle, we will be keeping it upside. Then little bit greater size, we are going to keep it in the middle. Then and a bigger size sand particle, we are going to place it at bottom. Similarly, here in gravel also, we are going to follow the same procedure. Very fine particle, we are going to keep it at top, medium at bottom, and the larger at the bottom. So what will happen? The water is going to pass from this particular layer of sand. Then if it is the water is going to pass through the pores, but suspended particles, if it is there, it is going to be get arrested, right? Then it is going to pass, the water will pass through the gravel, and then it is going to be collected through the under drains, right? And these are nothing but the under drains. So this is how we are going to remove very finer suspended particle which are present in water, right? Which are present in water, right? This is how we are going to remove. Now, why the reason why we are going to call this as a slow sand filter? The rate of filtration in case of your slow sand filter is very less. Okay, the rate of filtration in case of your slow sand filter is very less. So that is the reason why we call it as an the slow sand filter. Okay, that is the reason why we call it as an a slow sand filter. Okay, so we will see what are the how the water will come. Okay, the slow sand filters are, it is going to be invented in England, right, by James Simpson in the year 1829. Okay, and this is in case of your exam, right? In case of your exam, you are going to get a fixed question on this, right? With a neat sketch, explain the working of slow sand filter. With a neat sketch, explain the working of slow sand filter. You are going to be asked, right? The working part, construction part, right? And all those things it is going to be asked in your main exam, and you need to practice this particular diagram, right, for the examination point of view. So this is very important point, right? This is very important question in case of your exams. Normally, right, normally it is going to be asked in your exam. Okay, now we will see one by one how the water is going to enter, right? So here there is one wall will be there, right? There will be one wall will be there. From this wall, the water which has to be treated from coagulation sedimentation, it is going to enter, right? Or the sedimentation process, it is going to enter into the tank from this particular entry point. Then it is going to pass through the layer of sand. Then it is going to pass through the layer of gravel, right? So water is going to pass through sand and gravel layer, and then it is going to be passed through, it is going to be collected from into the under drains. From the under drains, it is going to pass, right? It is going to come over here, and the water, it is going to be flowed through the this circular where, and it is going to be get collected outside. The process is simple. The water will come from here, right? And it is going to pass through the sand and a layer of gravel, and then it is going to pass through the under drains. The from under drains, the water will be getting collected at the central drain. From the central drain, the water is going to be getting from here. The water is going to pass, as and how the water level is going to increase. It is going to be collected from the circular weir, and it is going to be collected outside. So this is how you are going to treat water in case of your slow sand filter. Okay. Now we will see what are the different components are there in this particular slow sand filter. Okay. Now first we are going to have is the enclosure tank, right? First point we are going to have is enclosure tank, right? So from this enclosure tank, right, it consists of an a watertight rectangular tank made up of masonry or concrete. Okay, this particular enclosure tank, we call this as an enclosure tank, right? This particular tank, we call it as an enclosure. It is made up of either BBM, that is burnt brick masonry, or with help of concrete. Okay, now here the bed, whatever the bed, this we call it as a bed, right? It is going to have, right? It is the bed, whatever you are going to see it over here. It is going to have the slope of around 1 in 100 towards the central drain. It is going to have the slope of around 1 in 100 towards the central drain. Here, in a further diagrams, we will see what is central drain. See, this is how the water is going to be get collected in the lateral drains. So lateral drains are nothing but these are the lateral drains. The pipes you are going to see in the cross section, we call this as an the lateral drains. Okay. So once the water is going to pass through sand and then gravel, it is going to be collected through the under drains. Now, from the under drains, this is nothing but the top view. Okay, this is your top view, right? From the under drains, here the bed, what we are going to keep it over here. This is we call it as an the bed of your uh, slow sand filter. So bed here, what we are going to have is we are going to have the slope of these lateral drains around 1 in 100. We are going to maintain the slope of around 1 in 100 in these lateral drains, right? The water is going to be collected through these lateral drains and then it is going to be collected through the central drain and then it is going to be collected outside. See, this is the top view at your lateral drain and central drain level. This is your cross section at the lateral drain or at the central drain level. So this is your cross section, right? From here, we are going to get the cross section here. We are going to get. So that is your lateral or the central drain. From this, the water will flow and it is going to be get collected here. Okay. So this is regarding how the working of your slow sand filter is. Right now, we will see the components. The depth of the tank, maybe it is the depth of your entire tank. It is going to vary from 2.5 to 3.5 meter. That is almost, it is going to vary till 12 feet, right? It is going to have a height till 12 feet, okay? And it is going to have the area, the area of this particular your slow sand filter. It is going to have the way area is going to vary in between 100 to 2000 square meters. Okay, so the area for slow sand filter, it is going to be vary in case up to 100 to 2000 square meters. See this, whatever the area, the depth, whatever I am going to tell you, this is going to be important in when you want to write the differences between the slow sand and the rapid sand filter. When we want to write the difference between the slow sand and the rapid sand filter, this particular all these values is going to be important when you write, when you are going to write the differences between the two. Okay, so this is going to be the important. So you need to know about the area, the depth, and the slope that we are going to maintain. Okay, so this is regarding your enclosure tank. Okay, then filter media. Filter media is nothing but your sand and gravel. The sand and gravel, whatever sand filter media, especially we are going to talk about the sand over here. Then here on gravel, we are going to discuss regarding it as a base material. We call it as a base material. Gravel, we consider it as a base material, right? So we will discuss regarding the sand. Okay, now filter media is nothing but the sand. The filter media is going to have the sand layers of about 90 to 110 centimeter depth. The filter media, what we are going to utilize it over here, it is going to have the depth of around 1.1 meter to zero point 0.9 meter. Zero point 0.9 to 1 meter depth. So 1.1 meter is nothing but 3.28 feet, or zero point 0.9, almost it will come up to say around 3 feet. So here the depth of your sand layer that we are going to use In case of your filter, here we are going to use the depth of around 1 meter. Okay, so you can consider it as a 1 meter. The effective size, okay, the size of the sand particle, what we are going to use is, it is 0.2 to 0.4 mm, right? 0.2 to 0.4 mm size of the sand particle, whatever we are going to use is 0.2 to 0.4 mm size we are going to use. Okay, and then the top 15 centimeter layer sand is generally kept finer, as I have told, right? As I have told, the very fine sand particle, we are going to keep it at top, then moderate at bottom, and the larger at the bottom. So this is the sequence what we are going to maintain it over here, right? So finer at the top, coarser, medium at the middle, and then coarser at the bottom. Okay, so the effective size of the sand, it is already told to you, the top 15 centimeter layer of the sand is generally kept finer, and then the rest, however, it is the different grades of sand is going to be used, and the coarsest layer we are going to use at the bottom. Okay, so this is why we are going to use the finer at the top is very fine suspended particle. It should be arrested in this particular area only. So that is the reason why we will be using very fine sand at the top. Okay, we will be using very fine layer at the top, right? Why is very fine suspended particles should be get removed in this particular region only. So that is the reason why we will be maintaining very fine suspended particles at the top. Okay, so this is regarding your this is and one more problem that what you are going to face in this particular top layer is, since we are going to remove very fine suspended particles at the top layer itself, there will be the possibility of generation of a sticky material, because this fine sand sometimes it is going to have some of the organic elements, say organic microbes or some of the very fine egg shells. If it is there is eggs are there of the microbes, it is going to be get arrested in this particular layer. So that during the cleaning part we will be discussing regarding that particular finer layer of your suspended particle, that we are going to discuss when we are going to come to the cleaning part. Okay, so then the base material, we will come to towards the base material. Now, the filter media, the base material is nothing but we are going to use this particular gravel, right? The your gravel, we consider it as an the base material. Here also, we are going to say following the same condition, right? Finer gravel will be at the top, moderate at the middle, and the coarser at the bottom. So here, right? So here at your in case of your base material, right, we will be using, right, we will be using the particle of, right, around 30 to 70 mm thick gravel, 30 to 75 mm thick, that is the depth we are going to maintain over here. This is up to 1 meter, right? 1 to your base fine sand we are going to keep till the height of 1 meter. But here we are going to vary the gravel bed from the depth of 30 to 75 centimeter. 30 to 75 centimeter thick gravel bed we are going to maintain. And each layer is of 15 centimeter. The 15 centimeter of the topmost layer will be of the finer size of the gravel, and the bottommost will be having the coarser material at the top. The 15 topmost 15 layer, 15 centimeter will be having the gravel size will be around 3 mm to 6 mm. Intermediate, right, will be around 6 to 40 mm intermediate layer, and the bottom layer, the size of the gravel will be from 40 to 65 mm at the bottom. So coarsest at the bottom, and each layer, right, fine, medium, and the coarser will be kept, right, will be kept with having the depth of 15 centimeter. We are for all we are going to maintain the 15 centimeter, right? So 15 first top 3 to 6 mm, middle 6 to 20 6 to 40 mm, in it is going to vary, and bottom layer we are going to vary it from 40 to 65 mm, right? So this is regarding under drainage, right? The whatever the filter media, that whatever we are going to filtered water, we are going to first we are going to get through the central drains, right? From the central drain, it is going to be get channelized into your central drain. From the central drain, we will be taking this water from the outlet over here, which is there. Okay. So this is how we are going to have regarding your under drainage system. Okay. The under drainage system consists of central and a lateral drain. These we call it as a lateral drain, and this we call it as a central drain, right? The laterals, right? The lateral are porous drains placed to 3 to 5 meter apart. This distance between, right? The distance between these two will be around 3 meters. Okay, normally we'll be keeping this will around 3 meter, and it is going to be sloped towards the central drain. Okay, the lateral collect the water and then it is going to transmit to the this particular central drain. Okay, so this is regarding your regarding your under drainage system. Then we will see some of the other apparatus what we are going to use, right? The other apparatus we are going to use for the filtration and all, right? The controlling the depth and the sand layer and all we are going to use. For example, what are the other apparatuses we are going to use is your circular wear and all, right? And then valves, right? We will be using it. So this is how we are going to have your working of your entire construction and working of your slow sand filter. Okay, entire construction and working of slow sand filter. In the next classes and all, we will be seeing how we are going to have the cleaning of our slow sand filter. Okay, is it clear? Is it
Yes, sir.
clear to you all? Slow sand filter.
Yes,
Anybody
sir.
is having any doubt? Yes, any doubts?
No, sir.
No, sir.
Okay, fine. Then we will take the attendance. If anybody is going to have any kind of a doubt, they can, meanwhile, they can ask, right? They can ask if they are going to have any doubt. Now, we'll take the attendance. We'll take the attendance and write your attendance in the chat box.